Welcome you all to this video lecture. So here we are going to discuss regarding to the topic instruction fetch and execution. So this is the continuation with regarding to the hardware component discussed over in the previous video lecture. So here this instruction fetch, what we are going to discuss here is the execution of an instruction can be divided into a sequence, which means a step by step in sequence. The first thing is that the process fetch. So fetches what instruction from the memory. So the next it will do the, which means the next instruction is going to decode that in order to get understand the required operation mentioned over in the instruction. So next is it need to require the operands, which means that are to be obtained from where register file ALU memory. After that, the processor performs the required operations, and finally it will write back the result over in that part. So automatically the thing is that the different instruction may not require all these steps is in exactly the same way. So however, this is what a basic flow normally followed in the processor. So things how the flow says is means the if instruction fetch, now id instruction decode, operand read opr, so execute, next is memory access, next is write back wb. So first thing which we are going to discuss is instruction fetch. So already we have lack of information over this, which means that more amount of information we have discussed in the instruction fetch. So this instruction fetch automatically does the process of the program counter accesses starting point of the instruction fetch operation. So from the program counter, it will goes back to the top what PC program counter. So from program counter instruction address, from there instruction memory, after that instruction, then the processor. So these are the things that get involved over the instruction fetch. So next is the how the loading of instruction into the IR instruction register. So from where it get initiate the operation means from the instruction memory IM, fetched instruction FT, next fetched instruction F5, instruction register and decode. The simple process is involved here is the program counter provides what an address, what address of the instruction. So while IR will do what store the instruction that has to be fetched. So next the updating the program counter process get involved. So at the same time the process has to be prepared what for the next instruction also. So therefore with respect to this what the program counter, it will do the process of updating to the point to the next instruction in the program sequence. Let's for an example, if the current instruction has been fetched successfully means automatically this PC moves to the address of the upcoming following instructions. So let's for an example, here I have mentioned a current instruction value as 1000 PC is equal to 1000 H. This is the hexadecimal value. Now it will what it performs the fetch instruction operation FI. So next the program counter is to get updated with respect to this instruction, and finally the next instruction address has been get involved. So the exact method of updating the PC depends on what, on the instruction size and the processor organization, but the basic purpose remains is what the same. So the PC should point to the next instruction that has to be fetched. Next is the instruction decode. So this instruction decode will tells us the processor what operation is required and which hardware resources has to be involved. The third step is the reading operand of reading the operand. So again I am using the same example as add r3 comma add r3 comma r4 comma r5. So using that, here the processor reads the content of what register r4 and r5. So these two values are supplied as an input for the next operation. A dual port register file has to be provided what the two register outputs simultaneously, which is the useful for instruction required for the two operands. So next is the execute operation. Here this execute operation performs as from the instruction add r3, r4 and r5. The ALU adds the content of what r4 and r5. So therefore, the execution stage performs what actual ALU operation, arithmetic or logic operations is required by the instruction. So the next is the thing which we need to get involved is the execution is different based upon to the of instruction. If example ADD means perform the addition operation, AND perform the logical AND operation, LOD load and store operation will performs the calculating of address operations. So here the thing is the same ALU can perform what different operation based upon the control signal. Here the control signal says this add is a control signal. So add is a control signal. Here it performs one operation. Finally, the ALU is also a control signal. It performs one operation. Load and store also a control signal that will perform a control signal. Another control signal, which another operations is also. So the next step involved is the memory access. So this memory access will performs as, which means that it stores the instructions, calculates the memory address, and writes the data from the processor into that location. So storing will depends us with respect to, so store operation get been involved with respect of the calculating of address. So through calculating of address, accessing memory, write data will be get processed. So the next is the write back. So the write back operations is get been involved with respect to the functionality of the store instructions is different because the data has to be written into the memory during where the memory access step. So a separate register has been mentioned. You need to that to perform this write back operation is generally not required over there. For load, it will data read from the memory is written into the destination register. This is the thing has been mentioned. So the next thing which we need to get a clear picture over here is the execution flow. So execution steps is how these execution steps is can be get with respect to the fetch and execution flow means first the PC program counter, instruction fetch IF, IR, ID instruction decode, and after that ID register read RR, ALU execute operation, memory access MA, and write back. So for this write back operation, which means that how the fetch to execution, here this is the basic flow program from the program counter. The instruction fetch operation has been performed. From the instruction fetch, it will get fetch over the instruction with respect to the instruction mentioned over there. After that, instruction register. So followingly that the decoding options, read operation, register read operation with respect to the source and destination register. ALU operations, executions, arithmetic operation or logic operation has been going to perform over that. With respect to the memory access, it will process all those data into that process. So the things is which been discussed over here is the fetch, instruction fetch, decode, register read, and memory access, execute, and write back. So simply I give a hint. Instruction fetch means that obtaining the instruction from memory, instruction decode, identifying the required operation, register read, obtaining the required operands from the register file, execute, performs the required operation using what? ALU, memory access, nothing that required for the instruction that the read or write memory performs. Write back means is what? Storing of final result in the destination register. Thank you.